All right, the first chapter of the book is called The Nature of Probability and Statistics. We're going to go over this right now, this stuff. Now, I want to say there's obviously going to be there are two videos on chapter 1, 1.1 and 1.2. The distinction there is not the same distinction as section 1.1 or section 1.2 of our book. So be very careful about that. Um, Section 1.1 of the notes covers a number of sections from the book. Okay, but it's all within chapter 1. So we start off with the idea of statistics. This is obviously probability and statistics, so we're going to start with the definition of statistics. Statistics is the science of conducting studies to collect, organize, analyze, and draw conclusions from data. Now, the idea behind that is that collecting, organizing, analyzing, and drawing conclusions, that's basically what we do anytime we do a study. And because this is what we do anytime we do a study, that's why statistics is applicable to such a broad range of topics and a broad range of fields. Basically, statistics is the machinery, the mathematics behind the scientific method. Now, the first thing we're going to look at are variables. Anytime we talk about statistics, we deal with variables. And a variable is simply a characteristic that can assume different values. So for instance, like height, hair color, eye color, education level, gender, those are all variables that you could apply to humans, right? So now, again, I want to make the distinction. Height is a variable. Your height, your particular height, is not variable. So height, as in the characteristic, is the variable. But for instance, 5'7" is not a variable. Now we're going to split variables up into two categories. One is qualitative and the other is quantitative. And I know you've probably heard these terminologies before, but I want to give a little bit of a subtlety to it. So qualitative, we have all probably heard before, that's qualities, and generally speaking, they don't have number values associated with them. And quantitative things are things we measure, things with number values. However, that's mostly the story. The real story is that with qualitative variables, ordering makes sense. All right, so for instance, or excuse me, did I say that? I said that opposite. Qualitative variables, ordering does not make sense, and quantitative variables, ordering makes sense. So for instance, let's say qualitative variables, something like hair color, we'd have all probably agreed that that is qualitative, all right? Hair color is not generally given a numerical value. And things like number of children or height or weight would be quantitative variables because those are all given numerical values. But something like number of children, ordering makes sense with. So for instance, I can say I have 2 more children than my brother has. We can order it from least to greatest, things like that. Whereas something like zip code, even though zip code has a number value for it, we don't actually call that a quantitative variable. That's a qualitative variable. So zip code is a qualitative variable because we wouldn't say naturally that this zip code is above this one or things like that. Zip codes have some relation to location, but that's not the complete story. Same thing with phone number. You wouldn't tell somebody that your phone number is 632 more than your friend's phone number. That wouldn't give them really any information about who to call. Again, they don't have a baseline judgment. But things like height, weight, we can say, yes, I'm 2 inches taller than my sister, or I am 3 inches shorter than my brother, something like that. So within the quantitative realm, we split this up again into two more categories. That is the discrete and continuous variables. Whole numbers or counting numbers are the discrete case. So things like 0, 1, 2, 3, 4, 5. In our last examples, children would have been a discrete variable. You can have 0, 1, 2, 3, 4, 5 children. You wouldn't tell somebody you have 6.38 children, okay? So only a finite or countable number of values is available when we're talking about discrete variables. Now, in contrast to that, continuous variables, any real number makes sense. So there's an uncountably infinite number of values. Now, again, this confuses some people when we talk about numbers. Generally speaking, when people talk about, like, for instance, their weight, they talk about their weight in whole numbers. They say, well, I'm 172 pounds, or I am 205 pounds. So that's a lot of the times we report it. However, weight is a continuous variable. And the way I always think about it is to say, can I add more decimals? If any real number makes sense, then putting on more decimals and getting a more precise number always makes sense. So I might say I'm 158 pounds. Well, somebody might get on the scale and say, well, actually, you're 158.2 or you're 158.21. And so as long as you can, the general rule that I use is that as long as you can add more variables, then it's a continuous quantitative variable. Now, what I would probably do if you're taking notes, if you're following along with the guided notes, obviously we talked about examples of variables, the qualitative versus quantitative variables. Any real number makes sense for continuous variables. I might also add under here what I would say, something like test by adding more decimal places. If we can, then we have a continuous variable, right? So we're judging the variable based on more decimal places. Hopefully, again, you've printed these out. Now I'm typing. I would obviously, if I had this in class, I'd be writing on this in class, okay? So hopefully you got that. Now, by the way, just as a side note, if you haven't yet taken a look, Chapter 1 notes, that is where both the PowerPoint that I'm dealing with and the guided notes that are in Word document form or PDF form, the printable version, is on there too. Okay, so in that category is where it's at. So anyways, the next thing we talk about after variables, it makes sense to talk about data. Now, data are the actual values that variables can assume. So like I was saying before, height is a variable. 5'6" is a piece of data. It's one data point, and we'll get to that next slide. Or hair color is the variable. The data is brown, right? College graduate, male, male is a piece of data. Gender is the variable that consumes. That's pretty straightforward. So data are the values. Notice that when I say values, I don't just mean numeric. We can mean qualitative or quantitative values. Now, just as a terminology, so I can start using this more often, a data set is what we're going to refer to as a collection of data. By the way, the word data generally is plural. So if I say these data, it's a plural term. All right. So data set is a collection of data. Data is a plural term. If I talk about a single piece of data, one individual piece of data, I usually on my videos use the word data point. Okay. You'll notice if you read the book, they also give you the word datum. Datum or data point is a single piece of data. Datum is the more sort of a proper way, but again, I use the word data point as a single piece of data. So we talk about variables, we talked about data. The next thing we need to talk about is what we're actually looking at. What are the either people or objects that we're actually interested in studying? And the group that we're studying is called the population. Now, I want you to be very clear on this definition. Population is all subjects being studied, all right? And obviously a sample is a subset of that population. So if we're looking, population is the bigger group. Sample is the smaller group. Now, population is, when I say all subjects being studied, oftentimes this being studied term throws people off. They think studied means they're being currently examined or currently experimented on. That is not the case. So the experiment is going to happen on the sample, but that sample is going to be used to study an entire population. So hopefully that makes sense. So sample, this is where a lot of times the experiment happens, but the population is who we're studying. So for instance, if I have a cancer drug that I'm testing, let's say it's for thyroid cancer, and I test this drug on 50 people, those 50 people would be my sample, but I'm using it to study everybody who has thyroid cancer. All right. So that's what the distinction there is. And then obviously a census is when the population and the sample are the same group. Okay. So every 10 years, the US does a census, and we try to study the population of the US by using everybody in the US. So making our sample everybody in the United States. Now, we don't do it perfectly, but we do it better than practically anywhere else in the world for such a highly populated country that we have. All right, so now we're going to break statistics into categories. And by statistics, I mean the study of statistics, all right? And we break this down between descriptive and inferential statistics. So for descriptive statistics, what we mean by that is that we're describing a situation. So we take a situation, whatever it happens to be, and we describe it. Maybe I say, my brothers, well, my family has an average height of 5'2". That would be a descriptive statistic. We could envision me measuring everybody in my family and then averaging that out. That average would be describing the heights of my family. Now, inferential statistics is where we take results of a sample and we project those onto the population. So we're inferring results of a sample to the population. Now, one thing that's kind of difficult about this kind of stuff is that oftentimes these will sound very similar. So you'll often hear a result that says, for instance, 40% of the United States approves of the president, or some other sort of statistical result like that. 40% of the United States approves of the president. Now, if you think about that, that sounds like it's describing a situation, but clearly they didn't ask every single person. So clearly they would have had to have gone out and gotten a sample, and they're using that sample to project onto the population. So the distinction here between descriptive and inferential statistics is to ask yourself, or let me rewrite that, did the study include the population that they are commenting on? All right. So let me give you a couple of examples. I'm not going to, this is a different slide, but so for instance, if I said 50% of people in the United States like a certain policy, that would be an example of inferential statistics because they didn't go out and collect data on the entire population. All right, let me go back here. Did the study include the population they're commenting on? I should have said the entire population that they are commenting on. All right, so did the study include the entire population that they're commenting on? That's sort of how I distinguish between descriptive and inferential. All right, so did the study include the entire population? Let me highlight that distinction by taking a look at a couple of polls that were done, and these are like hot off the presses as I'm doing this video. All right, so I went to the Pew Research Center. You can Google this, and there's the website you can go to. And right off the top, excuse me, right off the top page, they had two different studies. And they said more Americans are using ride-hailing apps, things like Uber and Lyft. And if you read along, it says today 36% of US adults say they have used a ride-hailing service such as Uber and Lyft. So again, would that be descriptive or inferential? Clearly, that's going to be inferential because 36% of all US adults, they probably didn't survey every adult in the United States. So they're making an inferential statistics. They're inferring results from some sample they did onto all US adults. Now, off the exact same page, they say 5 facts about the religious makeup of the 116th Congress. And if you look down here, it says 53.7% of the members of Congress, the House of Representatives, are Protestant or claim to be Protestant. That is a descriptive statistic because they have, in fact, went up to every single member of the House of Representatives and asked them for a religious affiliation. And they collected the data on all of those. Now, when I say they went up and asked, they might have checked a website or things like this, but these things are fairly easy to find. But you can see the difference. Even though both of these are talking about a percentage, the religious makeup and what percent are using Lyft, you can see that the one about ride sharing is clearly an inferential study. The one about the religious makeup of Congress is clearly a descriptive study. So be careful on the distinction between descriptive and inferential statistics. Now, one type of inferential statistics, and this is a very famous type, is called hypothesis testing. Okay? So hypothesis testing is one example of inferential statistics. It is actually the fill-in to right here. One example of inferential statistics is hypothesis testing. All right, that's what we're looking for. So what is hypothesis testing? Well, we're going to do this later in a very formal way, but to say it shortly, we want to start with some hypothesis, some sort of a statement which we can prove to be true or false, or at least we can collect evidence in favor of truth or in favor of falsehood. And I want to know if it's true on the entire group. And so what I'm going to do is I'm not going to test that on the entire group, but I'm going to test that on a sample. So my cancer drug, the example I had earlier, where if you give somebody a drug for thyroid cancer, you give 50 people who have thyroid cancer the certain drug and see how they react, that is a hypothesis test. All right? So you test it on a sample and you see if that sample, the hypothesis, holds true or not. If it does, then it's probably going to be true for the entire population. If the hypothesis doesn't hold true on the sample, then it's probably not going to hold true on the entire population. So like I said, we're going to do this formally in the later chapters of the book, specifically chapters 9 and 10. And we'll see sort of a formal process for statistically doing that. But I want to bring it up right now because it is such a famous type of inferential statistics. All right, so next thing we're going to look at is sampling techniques. We're going to look at a few different types of sampling techniques. Now, I know everybody's heard of a random sample. Now, the idea there is that we pick from a hat, that it's random in the sense, like it says in the notes, that it's not determined by a conscious decision, okay? So in the old days, that meant that we're not picking from, well, excuse me, that we're picking from a hat. So it's not a conscious decision that is determining how I get my sample. In modern days, for instance, when they sample US adults, they're going to have to figure out a way to get a sample out of like 300 million people. And so how they would do that is they'd have some sort of a big computer bank that can generate names of people to call for, you know, in the case you're doing a poll, in the case you're doing something else. All right. So a random sample means there's no sort of a conscious decision of who to pick or how this is coming up. Now that's slightly different than a systemic sample. A systemic sample is one where we pick every kth person. Now, what I mean by kth, k can be any number. And the reason you would do a systemic sample is because random samples aren't always really nice and easy to get. So for instance, if I want to figure out what people are buying at a grocery store, it would be very inefficient to try to get a random sample. Even though random samples are sort of the best case scenario that we can get, a random sample would be extremely hard to get in terms of seeing what people bought at the grocery store, because we'd have to collect everybody's name who went into that grocery store. Then we'd have to put them into a computer or write everybody's name down and put it into a big hat, and then we'd have to pick samples from there. So a systemic sample makes it a lot more efficient. Instead of trying to get a random sample from that grocery store, what we're going to do is we're going to wait outside that grocery store, and just every 100th person who walks out, we're going to put that person in our sample and ask if they want to do a survey and survey those people. This is how sampling is done with exit polling. So in the next election, whenever that happens to be, you'll see projections and you'll see exit polls if you watch one of those 24-hour news channels. And the way they do those exit polls is pretty much on a systemic base. Every 5th person that walks out of the polling precinct, that person gets sampled, or every 10th person that walks out, or every 100th person that walks out. And they'd probably set up in, key polling precincts and things like that. So a systemic sample is we have the system where we pick every 100th person, we pick every 10th person. Again, the number here, the K, depends on how many people I want in my sample and how many people are in my population. So if I want 1/100th of the population, 1/100th of the population, I pick every 100th person, and so on and so forth. Now, one thing that random samples and systemic samples sometimes miss is they miss people from not well represented groups. So from what I'll say minority groups, all right? I don't mean racial minority. I just mean minority in the sense that there's very few in my population. So for instance, if I wanted to do a study, and the study was to look at what groceries people with cauliflower ear were buying and what groceries people without cauliflower ear are buying, then what I would have to do is I would have to stratify people with cauliflower ear in one group and people without cauliflower ear in the other group. And I'd have to take a sample from each group, all right? Because even though I have cauliflower ear, it's a pretty rare occurrence that you walk around and you find lots of people with cauliflower ears. So if I was saying, by the way, for those of you who don't know what cauliflower ear is, it's what happens when your ear gets hit either a bunch of times or just a few times, and then some of the cartilage breaks and it fills up with fluid and it swells up and it hardens. So you get these big ears. A lot of times you'll see them on people like wrestlers or sometimes boxers. A lot of UFC fighters have them. Mixed martial arts people have them a lot as well. But again, lots of wrestlers and mixed martial arts people have them, but in the general public, they're pretty rare. So if I sat out and I did a systemic sample outside the grocery store and pick every 100th person, you would likely find nobody with cauliflower ear. All right. So what I want to do is I want to stratify people into groups so that every time I sit out there outside the grocery store and a person that with cauliflower walks out, I'm going to put them in my sample. And every time somebody without cauliflower walks out, I put every 100th person in that sample. All right, so I can make sure I get people from this minority group here. All right, so that's basically the idea of a stratified sample, that we place into groups and then we have some sort of a sampling technique on group 1 and some sort of a sampling technique on group 2. But stratified means we separate them out into groups and then take samples from each of the distinct groups. Okay, you see this a lot also in polling. They'll say, well, this percent of Republicans favor this bill, this percent of Democrats favor this bill, this percent of independents favor this bill, and so on and so forth. Now, the last legitimate technique that we're going to look at is what's called a cluster sample, okay? So oftentimes, again, the stratified sample is just separating things into groups, but oftentimes with the random and the systemic sample, it might take me a long time to get the sample. So a cluster sample is when we pick a group all at once. So instead of waiting and picking every 100th person that walks out of the grocery store, I pick the next 50 people that walk out of the grocery store at some randomly determined time, or at some random time. So I go and it's 10:14 a.m. and I say, well, I'm going to pick the next 50 people that walk out right now. And I put that as my sample. Okay, so that would be a cluster sample. And you see a lot of cluster samples in manufacturing settings and things like that. So with the manufacturing settings, they go onto an assembly line and they'll take 5 off the assembly line, like the next 5, and they'll inspect those. Or I saw this at, I didn't work there, but you can look up videos of people at meat processing plants, and they do this as well. They'll take, if they're processing turkeys, they'll take the next, 10 turkey carcasses off the line and look and make sure that they're all up to standards and fitting the standards and those types of things. So a cluster sample is you pick it all at once. Now, one thing I do want to mention about cluster samples is that you really have to be careful when you pick them. All right. So if I'm doing the grocery store example, it might be a disservice to use a cluster sample. All right. It might be a really bad thing for me to use a cluster sample in that setting. And the reason why is oftentimes you get different demographics of people, and people are buying different items at different times of the day on different days of the week. For instance, if you go in late on a Friday night and look at people's grocery carts at Meijer's, for instance, and then go at 10 a.m. on a Tuesday morning, you're going to see different things in those grocery carts. And oftentimes you see different people as well. Okay, I've been to the grocery store at all kinds of different times at night. That happens when you have children. All right, you'll have to make a diaper run or something like this. Some of you have children and you already know this, but you have to run out for diapers or run out for some crazy thing, medication that they need. And I've been there really super late on a Saturday night, and people are buying different goods than they are at 10 o'clock on Tuesday, 10 a.m. on Tuesday. All right, you see more older people. You see people who don't have jobs, don't have 9-to-5 jobs there at 10 a.m. on Tuesday. On Friday nights, who knows who you'll see, right? People might buy different things, meaning they may buy more alcohol towards the weekends and in the evenings than they do in the mornings and, at the beginning of the week, Monday and Tuesday. All right, so you might see those types of distributions. So be very careful about when you sample or when you pick your cluster sample. Probably actually not a good idea to do it at the grocery store, but you can, again, a lot of manufacturing settings, you can do this. Now, the last sample that we're going to look at is the one that we really should never do. All right, it's called a convenience sample. And the defining characteristic of convenience sample is that it's convenient. You pick your friends or you pick it in a way such that it's really easy to get. All right. And what that does is it's cutting out, or excuse me, being easy to get cuts out who may respond to it. So for instance, if I put up a poll on my Facebook page and say, hey, friends, what is your favorite chicken restaurant? And they respond, well, what's happening there? First off, maybe I want my friends to be my entire population. If I want my friends to be my entire population, then putting it out on my Facebook might be okay. But the problem with putting it out on Facebook is who responds. So what's going to happen is you get, let me step back. Facebook is going to filter who sees that and who doesn't see that. All right. So in order to see my survey, you would have had to have logged on to Facebook at the right time. And more importantly, you would have had to have been my friend, and Facebook's algorithms would have had to put that survey somewhere in a page that you'll see it. All right. So not everybody is going to see that survey. That's the whole point. And even if we put it like on a website, like an open website, instead of just my Facebook friends, maybe I pay YouTube to put it up in the corner as an ad on their videos. Well, who's going to watch that? Again, it's going to be very filtered to who's likely to click on that survey. All right. Again, if you put it on CNN.com or FoxNews.com or ABC.com, what's going to happen? Only people that visit that website are going to be able to take that survey. And the second big criticism of any convenience sample is that no matter where you put it, even the people who see that survey have to self-select in order to take it. So if you put up a poll on foxnews.com, the only people who are going to be interested in answering that poll are those who are fairly enthusiastic about whatever that poll is talking about. The same thing goes for any ABC.com, CNN.com, any news organization, any website. Think about my chicken example. If I said, what's the best chicken restaurants? Well, who's going to answer that? Well, people who are most passionate about chicken restaurants, one way or the other. If somebody's really passionate about KFC, they might answer the question. If somebody else is really passionate about Chick-fil-A, they might answer the question. But a lot of people aren't going to be very passionate one way or the other, and they're just going to ignore my question and move on. So because it's a self-selected survey, it's not a good sampling technique. So you should never trust any sample which has been got by convenience. And all surveys or all polling done by putting up a poll on a website or sending out a poll to everybody's email or sending out a poll to everybody's Facebook, those are all convenience samples. Those are all self-selected surveys, which are convenience samples. All right, So enough about sampling. Now we're going to look at a distinction between studies. Two different types of studies here. First off is the observational study, and secondly, it's an experimental study. Now, the root words there tell you almost everything you need to know. Observational study, you observe what's happening and then draw conclusions from that. All right, an experimental study is one where I am actively experimenting. I'm actively manipulating one of the variables. Now, again, be careful here because oftentimes results look very, very similar, okay? But ask yourselves, are the researchers actively manipulating one of the variables? So for instance, if I am outside a grocery store doing a systemic sample where I'm picking every 100th person and then asking them what they bought, that is an observational study, okay? I'm not manipulating any of the variables. I'm not doing anything that would cause somebody to buy different groceries. So all I'm doing is observing, seeing what people bought. An experimental study is one where I, separate rats into two groups. I give one this drug, I give the other nothing, and then see what happens. So I'm manipulating which group got the drug, which group didn't get the drug. All right. That brings me to the next thing. What are those two groups called? They're called control and experimental groups. So inside this fictional experimental study that I've done, I've given people from the control group nothing or a placebo. And in the experimental group, I've given them the real treatment. Okay? Now, let me state one thing here. I've done this inside an experimental study. Oftentimes, this language gets adopted by observational studies. So for instance, we may say, well, in this observational study, I was looking at what smokers were buying at Myers, what kind of food they were buying, and I'm looking at what non-smokers were buying at Myers. And you might call like smokers the experimental group and the control group non-smokers, or vice versa. So you might adopt that language, experimental and control, for an observational study. But this comes best, the language is used best inside of an experimental study. All right. I do want to mention the idea of a placebo. You see that word here? The placebo is just a drug that maybe looks like a real drug, but it really doesn't do anything. So a placebo is something like a sugar pill, okay? And there's been some really interesting studies on placebo. The first one is, well, why would we ever need a placebo? And the answer to that question is because they're effective. All right. There's something about the human psyche that will get better if they think they're getting a real drug. And not only that, there's been a number of experiments. The ones that I saw were from Duke University, in which the size and the shape of the placebo mattered. So for instance, a little white round placebo, people got better than if they were given nothing on average. But on average, if you make that little white round pill an odd shape and then color it, you're going to get better, people get better quicker. So the shape, the size of the placebo matter. In fact, in that same study, the little round pill didn't do as good as the odd-shaped colored pill. Something like, give them a blue pill, which is a hexagon, versus a round white pill. But In fact, I think the best pill that they got was a multicolored gel tab. So there was a whole hierarchy of pills and which colors did the best. And I think the best one in that study was the multicolored orange and blue gel tab. So all of these things had the same ingredient. They were just sugar pills. But the multicolor orange and blue gel tab was the best placebo that you could take as a pill. All right. And I'm sure if people were injected, maybe that would have made a difference. But as far as pill goes, round white was the worst. Then the odd shaped colored pills were kind of in the middle. And then the multicolored gel tabs were at the best. They were sort of at the high end. All right. So placebos matter. That's the whole point of that story. Placebos matter, and we give a placebo to the control group so that they think they get the real treatment. All right, because again, the human psyche makes a big difference. Now, also inside the experimental study, we're going to be looking at two different variables. So we're going back to categories of variables, and we're going to do independent and dependent variables. Now, independent variables, officially, it is the variable that is directly manipulated. So it is the variable that says, well, what type of placebo did you get? Or did you get the real treatment? All right, so the variable is real treatment versus placebo. The dependent variable is the outcome. That's like, well, how fast did you get better? So it's the variable that is influenced by the independent variable. Again, this is often adopted in this same language is also often adopted in observational studies too. All right. So people will say, well, let's let smoking be the independent variable, and the dependent is what did people buy? All right. What groceries did people buy? So, or, in another instance, the independent variable may be income, and the dependent variable is, what sort of neighborhoods did they live in? And so, again, we adopt the independent versus dependent language in observational studies often. Now, this is the end of 1.1. Hopefully, you've taken notes. Again, I've kind of flashed back and forth between the Word documents, the notes on the Word documents, and my overhead. In a real class, I would have just done the overheads, and I have sort of the Word document down on the table. But hopefully you can go along with that. Again, make sure you're either taking notes, writing things in, writing notes to yourself about how to remember things, being a good student, putting in the time it takes to take good notes and learn. At this point, you can start the homework. And I ask that you would do that. Just try the chapter 1 homework, do a few problems on there, see how it goes. Again, it's not due until Friday of the second week, but if you do it, if you start on it now, you get a good idea. Don't wait to the last minute to start it, because oftentimes what happens is, you might come up with a question, your internet might go out, some weird things. But try the chapter 1 homework, at least the start of it. Watch the next video, the 1.2 video, part 1.2, 1.2, I should say. And yeah, that is it for this video. Thanks for watching.